Welcome to this course on building agents on the Verisense network. In this section, we will explore how to create powerful autonomous agents that run on top of Verisense. First, we will start by answering a fundamental question. What exactly is an agent in this ecosystem? Then, we will walk you through a step-by-step process to build your own agent. Finally, we will show you how to interact with your agent inside SenseSpace, where you can test, refine, and observe its behavior in a live environment. By the end of this chapter, you will have a clear understanding of how to design, deploy, and operate agents on the Verisense network. Let us get started. On Verisense, an AI agent is an autonomous on-chain entity. It is designed not just to execute simple transactions, but to think, plan, and coordinate, much like a digital brain operating directly on the blockchain. This means it can understand high-level goals, decide what actions to take, and adapt its behavior based on changing conditions. It does all of this while maintaining a secure and transparent record of its state on-chain. At the heart of this system is a clear formula. An agent equals context plus tools plus L. Let us break this down. Context is the agent's on-chain memory. It stores critical information like goals, configurations, and the evolving status of its tasks, all directly on the blockchain. This ensures that the agent's decision-making process is transparent, verifiable, and tamper-proof. Tools are the agent's capabilities. These include powerful on-chain features such as threshold signatures for secure multi-party asset control, decentralized HTTP requests to safely fetch off-chain data, and on-chain timers that allow precise scheduling. These tools let the agent reach beyond static contracts and actively manage digital operations. Finally, the LLM is the reasoning engine of the agent. It interprets complex instructions, plans multi-step processes, selects the right tools, and adapts its strategy based on new information. This is what transforms a static program into a true AI agent. By combining on-chain memory, secure tools, and an intelligent planning engine, Verisense enables the creation of powerful AI agents. These agents can manage digital assets, process live data, and coordinate across decentralized systems, all in a transparent and autonomous way. Let us talk about the first key component of an AI agent on Verisense, which is called context. Context is the agent's memory and operational awareness. It gives the agent a stateful foundation, allowing it to go beyond simple, one-time transactions and handle more meaningful, multi-step tasks. This context includes several important parts. First, the goals and objectives. These are the primary missions the agent is programmed to achieve. For example, it might try to maximize staking rewards across 3 different protocols, or execute a trade when market volatility exceeds 5%. Next, the knowledge base. This is a repository of specialized information or historical data. The agent can draw upon this to make smarter, more informed decisions. Then, the session data. This acts as the real-time, short-term memory of the agent's current task. It captures conversation history, user preferences, and the live status of ongoing operations. Finally, the configuration. These are the agent's unique settings. They might include its risk tolerance, its security parameters, or its credentials for accessing specific tools. Now, how is this context stored? Verisense provides a flexible, hybrid approach to balance security, cost, and accessibility. For large amounts of non-critical data, context can be kept off-chain, in traditional databases or decentralized storage like IPFS. This is well suited for knowledge bases or long logs, where on-chain immutability is not always necessary. But for critical state information, such as the agent's goals, configurations, or the final outcome of a task, the agent relies on the Verisense Nucleus. Nucleus acts as a secure, on-chain storage and messaging layer. It ensures that the agent's core context is immutable, transparent, and fully auditable. Let us look at why on-chain context is so important for agents on the Verisense network. First, think of the blockchain as a global decentralized database. By using it as the agent's context, we make sure that the agent state is always publicly verifiable and consistent. It does not rely on any single party to tell us what's true. Instead, the data is secured by the entire network. Second, on-chain context enables secure multi-agent coordination. Multiple agents, or even human users, can independently access the same on-chain data. This means they can coordinate complex workflows, all while operating on a single, trusted source of truth. Third, Verisense Threshold Signature Scheme, or TSS, unlocks cross-chain context. With TSS, agents can securely manage assets and pull in critical data from other chains, like Ethereum or Bitcoin. This means an agent's context isn't limited to just Verisense. It seamlessly extends across multiple blockchains, giving it a much broader reach. In short, by anchoring context on-chain, we turn agents into truly decentralized, multi-chain aware, autonomous systems. This is what allows them to operate independently, transparently, and securely across different ecosystems. Now, let us look at the second key component of an AI agent on Verisense, which is tools. Tools are like the agent's arms and hands. They allow the agent to break out of the blockchain sandbox and interact with the wider digital world. These are the practical capabilities the agent can call upon to execute each step of its plan. Verisense supports a rich ecosystem of both off-chain and on-chain tools. First, off-chain tools. These follow what we call the MCP model, similar to multi-party computation. They let the agent securely reach external systems. For example, the agent can make HTTP API calls to fetch market data or interact with social platforms. It can connect to private or public databases to retrieve or store information. It can even run scripts in Python, JavaScript, or other languages to perform complex analysis. Next, and more importantly for trustless systems, we have on-chain tools. These are provided by the Verisense Nucleus. They let agents operate in a secure and decentralized way without relying on external trust. One of the most powerful of these is the Threshold Signature Scheme, or TSS. This is essential for cross-chain operations. TSS allows a group of network nodes to collectively generate a signature that can authorize transactions on other chains, like Bitcoin or Ethereum, without ever combining their private key shares into a single key. This lets agents securely manage assets and interact with decentralized apps across different ecosystems. There is also the on-chain HTTP oracle. An agent can submit a URL to the Nucleus, and Verisense validators will fetch the data, reach consensus on the result, and deliver it back on-chain. This is critical for agents that need to react to real-world information, such as current asset prices, weather data, or sports scores. Finally, there is the timer tool. This acts like a decentralized cron service. It allows the agent to schedule a function to execute at a specific future time, a certain block number, or on a recurring interval. This makes it possible to automate tasks like harvesting staking rewards every 24 hours, executing trades in a time-weighted strategy, or managing subscription billing. By combining these tools, the agent gains the ability to sense, decide, and act, not just within the Verisense network, but across multiple systems and chains, all in a secure and decentralized way. Next, I will introduce the A2A protocol and its role in the Verisense network. A 2A, or agent-to-agent, is an open standard introduced by Google in April 2025. It is designed for secure and decentralized communication and collaboration between autonomous agents. With this protocol, agents can automatically discover each other, exchange data, and coordinate tasks, all without any central authority. One of the core concepts in A2A is the agent card. An agent card is a standardized digital profile published by each agent in JSON format. It contains information about the agent's identity, its main capabilities, how to connect with it, and the required authentication methods. With agent cards, other agents can easily and automatically discover and interact with each other in a consistent way. The Verisense network adopts A2A as the standard protocol for agent interactions. Every agent in Verisense publishes its own agent card, enabling secure and automated discovery, communication, and collaboration between agents. This approach supports advanced scenarios such as cross-chain operations, distributed data analysis, and collaborative cryptographic computations. Next, I will show you a real example of an agent card on the screen. For off-chain agents, you can implement them in any way you like, but you need to make sure they support the A2A protocol. You can refer to the example in the GitHub repository shown on the screen for more details. On the right side, you can see an example of an A2A agent card. This agent card describes a bot called BTC Price Bot. It is an AI assistant that specializes in answering questions about the current price of Bitcoin. The agent can send push notifications and also supports real-time streaming, so users can receive instant updates. It communicates using plain text, both for input and output. The description tells us that the main purpose of this agent is to help users check the Bitcoin price. The skills section lists the main ability of the agent, which is to answer Bitcoin price questions. It even provides example questions such as, what's the current BTC price? And how much is Bitcoin worth now? Tags like BTC, Bitcoin, price, and AI help describe the scope of this agent and make it easier for other agents to find and use its service. The URL field shows where this agent can be reached, and the version number tells us which release of the agent is currently active. With this agent card, any other agent can easily understand what the BTC price bot does, what kind of interactions it supports, and how to connect to it. Now, let's move to the Verisense dashboard and click on Register Agent. There are two ways to upload an agent card. The first way is to provide the URL where your agent card is hosted. The second way is to directly upload your agent card as a JSON file. We'll enter the address where our agent card is hosted, and the dashboard will automatically fetch the agent card information for us. Here, you can see that the agent card information is now displayed on the dashboard. Now, let's click Register Agent to complete the process. At this step, you'll need to connect your wallet and pay a small amount of tokens to complete the registration. It's important to note that the agent card shown on the dashboard is for reference only. If you need to make any changes to your agent card, you should update it in your code or at the source where it is hosted. After making changes, you can resubmit or refresh the agent card information here. Our transaction has been finalized. Now let's go back to the Verisense official website. Click the SenseSpace button at the top right corner of the page, under the Product section. Next, click the New Session button in the bottom left corner. In the chat box, mention the BTC bot we just registered by using the @ symbol and ask it for the current price of Bitcoin. This will trigger the agent to respond with the latest BTC price information. Feel free to use your imagination and creativity to build your own unique agents. Alright, here we're going to show how to use SenseSpace to orchestrate tasks between multiple agents. In SenseSpace, we simply @ butler and tell it what we need. SenseSpace then automatically breaks this down into smaller tasks, assigns them to different specialized agents, and manages all the coordination behind the scenes. Each agent takes care of its part, whether it's gathering data, running analysis, or generating a summary. Finally, SenseSpace collects all the results and delivers them back to us in one neat response. And that's it. That's how easy it is to orchestrate multiple agents with SenseSpace.